Hello everyone, my name is Karan and I currently work at a Fabric INC as a ST2. I have worked with Razorpay and Rebel Foods before. Uh, Fabric INC is a e-commerce based startup based out of US. So to give a bit of more context about our product, so like what I used to usually like deal with. So our main product is a Copilot, and not Microsoft Copilot, but like our Fabric Copilot, which is a dashboard like that retailers use to manage their products, inventories, offers, promotions, customer subscription. It's a micro front-end based architecture. We use single SPA, TypeScript, React, and style components. We were in the journey of building our design system in TypeScript. So we had a design system 3.0 and we were migrating or building the design system 4.0 in TypeScript. And while we were in the process of migrating our products to design system 4.0, we wanted to measure like how our design system is getting used. Define our problem statement here. So like what we wanted to identify was that like how many teams and how many products are using DS3 components and how many DS4 components are getting used, if they are using any native HTML elements or not, if they are using any style components or like are they trying to override any style components or that. And also we wanted to create our tree structure of a page. Like if we have a page, we wanted to create a tree structure of a component so we can visualize how our components are rendered in the. So first thing first, so what we generally do is like Google the hell out of it, but like I couldn't found any solutions. And I was like getting this better luck next time. But after struggling for few days, I finally hit the jackpot. And I found this NPM package called React Scanner. So this was like a very magical thing if you go and look at the source code. So it's a static analyzer, like it statically analyzes the code, parses that code into AST, and it gives you the React component data and also the props details as well. So to give you a sample about it, like here is the sample code. Like you can see we have defined few JSX elements and we are importing from other files as well. So to give you the output of that React scanner, like how does it generate the output? You can see on the left-hand side, it's a raw output, and another on the right-hand side, it's a processed output. So it has a built-in few processors that you can use to process your data. Like one of the processor that I've used is the count processor. So it gives you the data at an overall level, like how many props are, like the number of props and number of instances of the component are given. On the left-hand side, you can see like there are few properties. We need to focus on the two main properties, like import information. So it basically provides like where this component was imported from and the props that it were passed and the location of that particular element as well. If there are multiple instances of the same element, then it will have an array of instances. So this is a React scanner in a flow diagram. You can see here it's simple stuff like reads the file, parses the code into AST, traverses the AST using a library called stray, and gathers information like component name, import information, prop information that we saw. And then it processes the data according to your processor. You can also pass your custom processors as well, and then returns the generated data. So to give you some information, like I don't have very detailed idea about AST, but whatever I have gathered from my experience using this library. So basically AST is a tree representation of your source code. So here I have a sample code, like couple of variable declaration and a simple function to add both of them. So on the right hand side, you can see the chart or the AST. Here you can see that variable declaration, declarator, and all this is represented using AST. There is a cool website called astexplorer.net if you want to learn more about AST. So here is the sample code that we had in our previous example here. on the right-hand side, you can see the AST. Here we need to mainly focus on JSX elements and the import declaration. Two type of nodes here mainly that we are using. So after using that library, we were able to generate this type of chart. So here you can see what all components were used from DS3 library versus from DS4 library. And here you can see the pie graph as well. And I thought, Hamjeet guy, we have done it, but that was not the case. We still needed to figure out all these points that were in the original problem statement. So next thing we generally do is fork the library and try to modify their source code. So we are now maintaining a copy of React Scanner in our code base. So to identify the native HTML elements from JSX, it's very simple. So you just need to check if it starts with the lowercase letter and it should not contain any dot. If these two criteria are met, then this JSX element is HTML element. So that was very easy to do. And using that information, we were able to show that data in our dashboard. Here you can see that A, H1, and P tags were used in our code base. Next is style components. So this style components support was not there in the React Scanner. So we as a team needed to deep dive into AST and figure out how to identify that. To focus on the style components, we use tagged template literal syntax. So here are a couple of examples that way you can use a style component. So using tagged template literals, this is the sample function that we wrote to extract the information of style components. So we are like, if you see here in the last statement, style CSS, we are gathering two information, style CSS raw and file path. And also the style from, like where are you styling from? Are you styling a button or are you styling any existing design system component as well? So using all this raw information, we were able to identify some of the anti-patterns that are followed by product teams. So anti-patterns basically means like things that you shouldn't be doing. Like you shouldn't be using hard-coded colors. Instead you should be using design tokens. And you shouldn't be using anchor tag or input. You should use like link component or an input component from your design system. So using all the data, we were able to see or display this data into the dashboard that we built, and like we asked him to take corrective measures like use button from design system, or like don't use hard-coded colors used from design tokens. The last bit about component tree structure is that we wanted to visualize how a page is represented in terms of our design system components versus non-design system components, like that. So we had a user form. So we had a user form, like we had a manage users page where it has a user form plus a user list. So here you can see we are visualizing this with that, and we can already see a one anti-pattern if anybody notices here. So here you can see we are using 3 instances of snack bar. We shouldn't be doing that. We should be using only one snack bar and pass the different props. So this is the base tree structure. We plan to add more features like visualizing, adding more data about what all components, like if it's used from DS3 or DS4 or much more. So yeah, in summary, like we were able to gather the information like how overall our design system is getting used. Based on the data, our team were able to take data-driven decisions around major components like that were mostly used by the teams, and we were able to also highlight the anti-patterns that were followed. Yeah, thank you. Thank you.